Hello, welcome everyone to the post-contest discussion of Codeforces round 897. I'll start with question number A. So in the question number A, there is a given array of length n. We have to find a permutation B of length n such that the distinct numbers element-wise difference between array A and B is maximized. That is, if I consider this case 3, 3, 10, 3, 3, 3, 10, 3, 3. If we take a permutation of 1, 2, 3. So what will happen? This 10 will get to 9. This 3 minus 2 will be 1. And this 3 minus 2 will be 0. So there will be 3 different elements. And let's take another permutation. 7, 8, 9. If I take 1, 2, 3 in this array, the answer will be 7 minus 1 equal to 6. 8 minus 2 equal to 6, 9 minus 3 equal to 6. One thing you can notice in this question is if we start from the permutation from the beginning, like if we sort the array first, given array, and take like the subtraction of like difference between the permutation and the array, it will be like there is a probability that the whole permutation will be equal, because we are subtracting the same amount from every number. Now, if we just reverse the permutation, it gets to exactly opposite. We are subtracting greater value from the less number. So there is a very less probability of coincidence. And if I subtract 7 minus 3, it will be 4, and 8 minus 2 it will be 6, and 9 minus 1 it will be 8. You can see the probability of getting like same number is very less. So what we'll do in this question is we'll assign the lowest number to the greatest number, like lowest number in the permutation to the greatest number in the given array. So we'll first sort the array and assign the like value n to the lowest number. Like if you can see here, I have assigned 3 to the lowest number, and I have assigned 2 to the the second lowest number, and so on. So you can see the implementation. First, I have taken input in a pair of factors. I've stored x and I. X is the value of the array, and I is the index, because I have to rearrange the like permutation as in the index, like as per the like I have to output 3, 4, 7. But if I get like if my array is like this 9, 8, 7, the 3 should be here. 1, 2, and 3. 3 should be corresponding to 7. Okay. So you can see I've sorted the whole pair of vectors, and I have assigned each indexes a value. Like I've started from n, I'm assigned the lowest value, the greatest number that is possible in the permutation, that is n, and then I subtracted 1 every time I've assigned a number. So that is all. You can see the output also for 10, 3, 3, the output is 1, 3, 2, and 1, 2, 3 will be also fine. Let's move on to the next question. We're given a string as we have to output, like I have to check if there is a possibility of getting a palindrome after we XOR this string, given the given string with is another string that has k element of k ones. Okay. So let's see an example. Simple example will take 101. We can XOR this first one with 0, 1, 0, or if I XOR this is 0, it will not change anything. If I XOR this with 1, then this value will get to 0. This value 1 will get to 0. And if we XOR this, if we don't XOR this, the last index, then what will happen? It will be like if I XOR this with 1, if I don't XOR this, if I don't XOR this will be like this. And this reduces a palindrome. So the thing is, what we can notice is if I XOR like if there is a two elements equal in the given string, that is si and s and like this one and this one, like corresponding element. If we XOR one of them and both of them are equal, then this breaks an palindrome. So we have to XOR both of them or XOR none of them. Okay. So for this case, if we take the string as 1 1 0 1 1 0 0, so you can see this 1 and 0 is not equal. This 1 and 0 is not equal. So we have to XOR one of them with 1 to make it palindrome. So if I have like 1 1 1, so I will XOR this with this one, so it will be 1 0 1. If I have 2 1, I'll XOR with this one and this one. If I have 3 1, I will XOR this one, but I will have to XOR this one also. I will have to XOR this one also. So it will break and palindrome again, because everyone with sense this will become like this. So what happens? We can notice that if there are k different elements, like k pairwise, not like that, like not equal elements, we can say, that is respectively that this or one corresponds to this index. Like if I take a longer string 1 0 1 0 0, this one corresponds to this, because these two all we need to make a palindrome. We have to balance these two, and we have to balance this one only. So if we check if there is 1 0 and if like one non-equal pair, there is only one non-equal pair, so we need at least one 1 to make this a palindrome. And also we cannot have all the string whole string as 1 1 1, because this will also break the palindrome. So what we can see that for that, 1 is possible, 0 is not possible, 1 is possible, 2 is possible, because I can XOR this one with 2. This will not change, because this for odd numbers, this I can XOR this with anything, and this will not break and palindrome, or this will be always pairing, because this has no pairs corresponding to it. So I can take anything else other than like last and first. And let's check for another string 1 0 1, sorry, 1 0 1 1 0. You can see we need at least 2 ones we have to XOR this one or this one to make palindrome. So for 0 ones, like 0 case, this is not possible. For 1k, this is not possible. For 2 case, it is possible. For 3 case, it is possible, because I can XOR this with 1. And then again for 4 case, it is not possible. For 5 case, it is not possible. So you can say this is like a pattern. We are outputting like k zeros, like if I take n pairs are not equal, k pairs are not equal, we are outputting k zeros and k zeros here, and bits in the between we are outputting 1 1. So for odd cases, the answer is like that only. You can check here n equal represents how many pairs are not equal. You can check for the first NEQ up to 0, for the between part I have output 1, and for the rest part I have output 0 again. So answer will be 0 0 1 1 0 0, like that only. And for even, what will happen? Like if I take this as even, I have to always take n pair. Like if I want to balance this, I can take this one. I have to take this one or this one. And after that, if I have two ones, if I have one ones, I can just XOR this with this, and this will become palindrome. If I have two ones, I cannot do it because I have to XOR this one with this one. But if I XOR any other indexes with one, it will break the palindrome. But three is possible because I'll XOR this and this with three. So that is the answer. Here also the same, the pattern is same. First, not equal numbers will be 0. Then that previously we are outputting 1 1 1 and 0 0 0. But for this time, this will be like 1 0 1 0 0 0. Like 1 1 1 will be there, then 0 will be there, because we have to take either. We cannot increase odd number of times this, like, because we have to either take 2, like k or k plus 2 to maintain the balance, or k plus 4 or k plus 6, like that only. So between that, k plus 3 and k plus 5 is not possible. You can see here this output is this. So my code looks like that only. For first n equal numbers, I have outputted 0. Then the between ones, I have outputted 1. That 1 corresponds. I am changing the 1 each time after outputting it. The whole solution will be. Now let me go to problem C. Hmm. In this question, this is an interactive question. The first thing we notice is that we will be playing against the program only. We have to give an input. We have to guess the we have to guess the number in a way such that the thing we output will be the optimal one. Okay. So we are given a set of n distinct integers, and we have to output input like x, and s must not be contained in the number. That is, x should be this thing also. Then Bob removes y. That is the program removes y. We are adding x to the set. Program is removing y to the set, and that is also, there is also, you can see the number y must be strictly as in number added by alias, that is x. So the thing is, you can notice is if alias inputs 0 in the string, 0 in the set, then Bob cannot input anything because there is nothing less than 0. Bob cannot erase anything because there is nothing less than 0. So the game ends when Alice takes 0 as 0, inputs 0 in the string. One thing you can notice in this question, that is the first thing you can notice. Then that's the second thing you should notice in the question is, let us consider we have the array this 1 2 3 5 7. So Alice is trying to maximize the answer. So here the max is 0. Like, we don't have 0 in this thing. So to get a maximum max, we have to, Alice must have to input a 0 in the set. So Alice will input 0, 3 4 5 3 5 7. So next move, Bob cannot move anything. So let's take another array. Let's take 1 2. We don't have 2. In this case, what happens? Alice have to input 2 because that will increase the max to the maximum. So Alice will just put 2 here, 3 4 5 3 5 7. Then Bob will also try to minimize the answer. So Bob will always remove something from here that is lower than last 3. So Bob will remove 1 or 2, or Bob can remove 0 also, 1 3 3 5 7. Then again, what Alice has to do is, because Alice has to maintain the max, Alice will always insert the removed number in the set, because to maximize the max, she had to like input 0 in the set only. 0, 1, 2, 3, 5, 7. So you can see that here the process ends. So the question resolve how to this whatever Bob removes, add that in the set only. So that is the whole question for to answer n plus 1 times. So first thing we are calculating MEX here the first number that is not present in the array. We're calculating that. Then I'm inserting max to the answer because that will give the maximum answer possible. Then whatever Bobs removes, I'm just inserting that to the answer, and that is the whole solution of C. Now Agras will continue with D. Hello, Agras.
Hello, am I audible?
Yes, yes.
Dimple, am I visible?
Yes, yes. It is visible.
So this is question D, and it is given that we have an array of length n. Initially, the array is full of zeros. Right? Initially, the array is full of zeros. However, we have to make the array into B by doing operations. The operation is as follows. The operation is having choosing an array of length L, where each element of L should be between 1 to n, and the order can be jumbled. Or the order can be any, and all Li are distinct. And we have to change each element from A of Li to L of I mod k plus 1. I will make you explain this. We become interested in whether it is possible to get a B. So we have to check if it is possible to be get a B from A or not. So basically, that's that we will be given two input n and k. So the second line must be, and every element of B is from 1 to n. So we have to output is same. So the question is pretty much simple. So let's move on to the approach. So if you just print yes or no. So so basically the question here represents we have first the first we have array A, which was initially, for example, for size n. Right? So we have initially n. Then after we have to convert it to array B by also we have k. So to make it like B, to make it B, we can apply operations. In each operations, what we can do is we can select an array with array of size L. We can select array, let's say array L of, uh, of size k. Of size k. Okay. So what I can do is let's see if the elements of Li are Li L1, L2, L3 to L3. Now, what we have to do is in array A, we have to set A of 1 to L2, A of 2 to L3, A of 3 to L4, and like this A of K to L1. So see, we have to do a cyclic formation type. So we have to make A1, L2, A2, L3, A3, L4, and AK, L1. So within the given constant, let's see the first test case, right? The first test case is this. First test case is 53235. First test case is 5323. 53235. 3, 4. So this is array B. So to what we have to do is we can just apply operation like L. For example, the first operation will be 1, 2, and 3. So now initially our array is like this. So after having this operation, we have to set A1 to A2 to 3 and A3 to 1. So now the array A will look like 2, 3, 1, 0, 0. Let's see having next operation. Next operation is of 3, 5, 4. So A of 3 is 5, A of 5 is 4, and A of 4 is 2. So now the array will look like 2, 3, 5, 3, 4. So we got the answer. So we have to print this. So now this is all about the understanding the problem. Now how to approach this question. You see, for achieving a BI, for achieving every BI, for example, like we have to achieve BI, right? So what we have to do is, for example, we have to achieve BI in the ith index, right? So if we have to get the value in ith index of BI, so for some subsequences, so for the last subsequences that have to be executed, L of I, L of I plus 1, this one L of K, and here L of 1 will be there, right? So here it will be of I and it will be of BI, so that I will have to check the value of BI. For example, in the last case, like 2, 3, 5, right? For example, 2, 3, 5, 3, 4, right? So here the index will be 1, 2, 3, 4, 5. So so the last value that will be executed in the index 3 will be of like 3, 5 in here in the array L, right? So so that the value A of 3 can get the value of 5. So yes, so we can now say that for uh, for having such all conditions, right? For example, B1, B2, B3, B4, B5 to Bn, and every index 1, 2, 3, 4, 5, and right. So we have conditions that for the last iteration, for the last thing, one should be coming, Bi should be coming after one, two should be coming. This arrow means after that have to become. Two should be coming before. B2 should be coming before after two, and B3 should be coming after three. Four should be coming 4. So like this for n, n, right? Yes. So you see here every vi is between 1 to n, right? So basically what we are getting is we are getting some conditions and we are approaching a question of uh, like it's approaching a question where it is a directed graph. It is a directed graph question, right? So so it's a directed graph. So how to now you see here for each index I we have to go to just bi. So for each index, if we take index I as a vertex, then we have to go to BI. So here the out degree will be always 1, but the in degree can be greater than is equal to 0, right? So now the graph will be pretty much simple graph, but it can exist cycle. Now what if there is a cycle, right? For example, if see we have k is equal to 3 and we have graph like this. Please, let me see this. And also here the graph will always have to terminate in some point. So it will have to be terminating. At last it have to be terminating in some cyclic. Okay. So now you see. So after doing the first move in these three, we can just make that these three possible, right? Then you see what I can do is this, after making these three, we can just iterate over this cycle. Like for k is equal to 3, we can just for by single iteration we can do what? We can just take over this with, right? Let's see for by giving an example, the previous example, 2, 3, 5, 3, 4, right? So here 1 will be coming to from procedures 1, 2, 3, 4, 5, 1 to 2, 2 to 3, 3 to 5, uh, uh, 4 to 3, so 4 to 3, and from 5 to again 4, 5 to again 4. Now you see here, in our case has there 3, right? So what I can do is I can select this part, this non-acyclic part, this single group, and I can recover these values, right? I can recover these values. I can do what? I can have a Li value like 1, 2, 3, right? So what I can do is I can put A1 to 2, A2 to 3, and A3 to 1. I do not care about the A3, right? But by this doing this operation, our A2 and A3 are gone the same required values. Okay. Now, what I have to do is my required value should be containing my concern is up to now this because it is a terminating cycle. And now you see this terminating cycle is of k is equal to 3, which is same as the size of the cycle is 3, right? And also also k is equal to 3. So we can do what? By having a single go, we can just put a of 3 is equal to 5. That yes, a of 3 is equal to 5, a of 5 is equal to 4, and a of 4 is equal to 3. So this will directly make our solution possible. So the first condition is that if there is a cycle present, if cycle, then it has to be of size. It has to be of size k. It has to be of size is equal to k. Okay. Now here, in edge cases will come when we have k is equal to 1. For example, if our k is equal to 1 is so if k is equal to 1 is there, you can see that the graph will be of, the cycle will be of size 1, right? So for example, 2 to 2, 3 to 3, which will be only possible in the case of the permutation like 3, 1, 4, n is equal to 5. Let's say this will be the answer. Only if k is equal to 1, this would be possible to make. Or else the conditions is just false, right? Yes. So now the code is basically pretty much simple now. Um, Also, I want to just tell you that, for example, we have some size, we have some long, suppose a long array. And after that, we have a cycle of size. So what if our values means, for example, this is k, right? So if our k is, for example, like 2, right? So what I can do is I can just put first two and I can make them required, right? Make them to required. And then again, what I can do is I can select these two and make them according to our required value. These two again required value. After this, these two required values. So then after that, I can directly select the size of k and make it possible to the required value. So this is basically the approach. So if there is an so basically the intuition is if the cycle exists, it has to be of size k or else the solution doesn't exist. Let's move on to the solution. Okay. So here basically I have to move out this. So here first I have taken the input of the graph to of course clear it out. Also, if I have externally handled the k is equal to 1 case, so for example, if k is equal to 1, I have to just check if the permutation like 1, 2, 3, 4, 5 like that exists or not. If not, then we have to just print it. Okay. Or else what I have to do is I have to make this graph. So I have taken input to the graph. And then what I use is, you see, uh, having doing a DFS traversal in a cyclic graph to find a cycle, in directed cyclic graph, find a cycle, it's little bit tricky. So you have to color the graph into some iteration. Is it every time you just get a visited array, maybe it should not be cycle. So in one go, if our color will be the same of coloring the graph, of course, you can color the graph in different integer according to your traversal. So yes, what I have to do is I have taken this enum variable, which will be my color for that iteration. So again, now the DFS part. So here in V will be the vertex, here num will be my color, and K will be of course the K value. Okay. So my visited will be right. This time my visited will be num, right? So if so again, after, by traversing, if there is a visited, then if there is visited, and the visited thing is the color that I am now exploring, right? Exploring with, then of course I have encountered a cycle, right? Yes. So now what I have to do is I have to just make sure that the cycle, make sure that the size of the graph, size of the cycle that I had just got is size k or not. Of course, it will be in values, it will be k, right? Yes. Or else what I have to do is I can just increase the value in value of the current vertex that I'm doing by just incrementing the value of parents plus one and just doing the traverse. If any of the vertex, any of the children give false value, then I have to return the false value. That's have to repeat. So yes, it is pretty much simple question. Hello, Dimple.
Yes, yes, I
Okay.
guess. And here.
Okay.